Alright guys, so today we're going to start off with some things you have probably heard before, and you've probably heard them in math class, but in physics class you're going to be so overhearing them because we're going to use them over and over and over and over and over again. So today we're going to talk about scalars and vectors. So the definition of a scalar is a quantity that has only a magnitude. But what's a magnitude? Magnitude is a value. So the scalar is something that has only magnitude, which is a value. It doesn't have direction. And that's going to be really, really important. So scalars have no direction. And to help me visually remember this, I'm going to put a circle over it with a line through it. Scalars don't have direction. No matter what we do, scalars don't have direction. So they just have a value. You might think that you've never heard this in science, or what measurements in science just have a value and don't have a direction. But most of our measures, when we're outside of physics and we're thinking about things in biology or things in chemistry, are all going to be scalar measurements. So scalar measurements are going to be things like we see over here. So they're going to be temperature. That's definitely a scalar measurement, like it's 2 degrees Celsius. There's nothing that has a direction with that. Some other ones, like up here, for a scalar value, we have mass. Mass is an SI unit, but it's also scalar. There's no direction to mass. It takes up as much space as it takes up. Another one is volume. We spend a lot of time in physical science talking about volume. So you've got your height, right? And you've got your width. And you've got your length of your box. Volume equals length times width times height, right? So examples. So scalar examples would be things like it weighs 1.5 kilograms. It's 2.3 centimeters long. It doesn't have a direction. Something has 100 calories. Believe it or not, calories is a scientific measurement. So those are all different examples of scalars. Vectors are like a scalar, but they have direction. So our actual written definition of a vector is a quantity with magnitude and direction. And that direction piece is really important. That's why there's arrows all over the bottom of this page. We're going to spend a lot of time in physics talking about vectors, what direction they're going in. It's going to play a really, really big part about what we do in this class. And the way I remember it, this sounds really weird. The way I remember it, though, is if you think about Despicable Me. In Despicable Me, the villain is named Vector, and in the movie he has this whole line about how his name is Vector. He is magnitude and direction. So that direction part is what makes him really important and different. And in physics and physical science, those vectors are extremely important because of that direction they go into. So when we write a vector, we're going to use vector notation. So the first thing we're going to write when we use vector notation is the magnitude. So 2.5 would be my magnitude. It's my number. The next thing we're going to write is the unit. For my example, I use kilometers. The last thing we're going to write is the direction. So for example, it's north 10 degrees west. We're always going to put that direction in brackets so we know it's the direction. That's something some scientists do, some scientists don't. It's the way I prefer it. It kind of sets it apart so you don't get it confused with a variable or anything else when you're doing your math work. So scalars have just a magnitude. So it's just a number and a unit. Vectors have a number, a unit, and a direction. The way we determine directions in science is over here, and it's a compass. So we're going to use this compass to help us determine directions. You've got north, northeast, east, southeast, south, southwest, west, and northwest, like the singer's daughters. So some things that we'll measure with vectors will be the direction you travel. You traveled 2.5 miles west. You traveled 2.5 miles north. How did you get home? We'll also use vectors to determine force. So this over here is called a spring scale. And this little spring scale, you've probably seen them or heard of them as luggage scales. You put, or you can use them as luggage scales. You're going to put something down here and it's going to pull down. And it's going to measure the force in a direction. And for this instance, it's measuring the downward force. The last thing you really need to know about vectors in your notes is going to be really important is you always use brackets. So those vectors are always going to go in brackets. At the bottom of this page, or all you have left to do, is identify which of the following are vectors. So I'll do the first few with you, or this first column with you. I'll leave you on your own to do the rest, but of course I'll give you a page where you can check them. So let's look at the first one. It's 7.6 meters. So we said here, let's zoom out some so you can see my whole page. Sorry, I've got a new cam. I'm still trying to get used to it. Okay, so if we look down here, the first thing we have to look at is 7.6 meters. So it has a magnitude, it's got a unit, but it's missing a direction. So it can't be a vector. 19.6 north, left. So it's got a magnitude, which is your number. It's got a unit, that's newtons. I don't know why I said north. And it's got a direction. So that's definitely going to be a vector. It's got all three things we're looking for. Underneath that, we have 12 volts. It's got a magnitude or a number. It's got a unit, but there's nothing in brackets, so it's not a vector. And the last one I'm going to do with you, we have 45 kilometers per hour, north 20 degrees west. So we've got 45, which is our magnitude or our number. We've got kilometers, which is our unit. And we've got north 20 degrees west, which would be a direction. So this has all three. This is going to count as a vector as well. So you can go ahead and do the rest on the bottom of this page just to get you familiar with what vector notation looks like. And that should be all for notes on scalars and vectors. As we start working more and more through the unit, I'll start giving you a little bit more at a time on vectors. I don't want you to get overwhelmed all at once. We're going to ease our way into it.